learners, welcome to this lesson. I'm teacher Agnes and today we are going to be discussing about the circumference. So the circumference is just another word for the perimeter of a circle. In the previous lesson, we were looking at how to determine the perimeter of different figures. And for a figure like a rectangle, we agreed that we just need to add the length of all the sides, and then the total length will be equivalent to the perimeter of the rectangle. The same case applies to other figures that have different number of sides, like a triangle, a trapezium, and so forth. Now, a circle does not have sides because, it's circular. You cannot have the length for, it doesn't have sides basically. So how do we determine the perimeter of the circle? The easiest way to determine the perimeter of a circle is by taking a string or something flexible and start at one point, then wrap the string around the circle, mark the beginning and the end on the string. Then take out the string, straighten it, place it on a ruler, and then determine how long that string is. Now the length of the string would be equal to the perimeter of the circle, which we are referring to as the circumference. So circumference is just the perimeter of the circle. Now that's how you measure. That's how you measure the circumference of a circle. So how do you calculate? How do you calculate the circumference of a circle? Now a circle can be divided into two equal parts using a line that runs from one side to the other. Now this line is known as a diameter. So a diameter is a line that divides the circle into two equal parts. So this side is equal to this side. Now the diameter passes through the center of the circle, and half the diameter is known as the radius. So half of the diameter is known as the radius. So we have two radii. So even here we have a radius. If you have more than one radius, we refer to them as radii. Okay? So according to this, we can derive the relationship between a radius and a diameter. So a diameter is made up of how many radii? Two of them. So D is equal to 2R, and this is a relationship that you want to remember. So the diameter and the radius can be used to calculate the circumference of the circle. But before we learn about the formula, I want us to first watch a video that explains the relationship between the circumference and the diameter.
What do we get when we divide the circumference of this coin by its diameter? What about this wheel's circumference and diameter? Or this stadium? Or the earth? Recall that the circumference of a circle is the length of the edge or boundary of a circle. In other words, it is the perimeter of a circle. Coming back to the question, whenever we divide the circumference of a circle by its diameter, we get the same value every time. Can you recall what this value is? It is pi. Remember that pi is an irrational number. This means that it is a non-terminating and non-recurring decimal number. The digits after the decimal keep going on and on and on. That is why it is non-terminating. And since there is no repeating pattern in the sequence of digits, it is also non-recurring. As it is not possible to write down all the digits in pi, whenever we have to write pi, we simply use the Greek symbol pi. In calculations, we can't use an endless value. So we use approximate values of pi, such as 3.14 or 22 divided by 7. So now we have learned that the circumference divided by the diameter of a circle is always equal to pi. Let's connect this with something we already know.
Now, in that video, you have realized that when you use circles of different sizes, and you take the circumference of each circle and divide it by the diameter of each circle, you are able to obtain a certain value. Now that value is the same for each circle. So there is a relationship between the circumference and the diameter of a circle. If you take the circumference of a circle, divide by the diameter, you will obtain the same value for every circle, and that value is actually known as pi. And that is how we write pi, which is a Greek letter. The spelling for pi is pi. So pi is a Greek letter that is written like this. Now this pi, what is the actual value of pi? So you have realized from the video that pi is equal to 3.142 and many other decimal places. So pi is a number that never ends. It is non-terminating decimal, but when expressed as a fraction, pi can be approximated to 22/7. So when using pi to calculate the circumference of a circle, some questions specify that you use either 3.142 or 22/7. Other questions do not specify at all. So what you do is that at that moment you choose the one that works best for you, and then proceed and use it. So from here, from this relationship, we can be able to to come up with a formula for calculating the circumference. So circumference over the diameter gives you pi. So if you cross multiply, okay, we will have the circumference being equal to pi times d. Pi d. So we say that the circumference of a circle is equal to pi d. Now, we already said that the diameter is equal to 2r. So what if we want to determine the circumference using r, the radius of the circle? So we will just substitute here. C is equal to pi times 2r. So if we multiply this, and based on the rules of algebra, 2 comes at the beginning, so this will be 2 pi r. So the circumference can be calculated using the formula C is equal to pi d, or C is equal to 2 pi r. So now we are going to do some questions to try and use the formula and calculate the circumference of different circles. So now we are going to work out these two questions. The first one, find the circumference of a circle whose diameter is 35 centimeters. So in this question, we have been provided by the diameter as 35 centimeters, and from our own knowledge, we know that we will need pi. And because pi has not been given in this question, we can use any of the two. I'll choose to use 22/7, and I will explain why. So we know that the circumference is equal to pi d, and this is equal to pi is 22/7 times the diameter, which is 35. So 7 and 35 are divisible, and that is why I decided to use 22/7 to avoid working out with decimals, because you can bear with me that when you are doing multiplication with decimals, the risk of making an error is higher than when you are not dealing with a decimal. Now, since 35 is divisible by 7, it is better to choose to use 22/7 than 3.142. If the question specifies that you use 3.142, then please follow the instructions in the question. So divide by 7, we obtain 1. Divide by 7, we obtain 5. So now we have 22 times 5, which is equal to 110 centimeters. Now remember that circumference is a length. So the units are not squared, they are not cubed, they are just, centimeters if you are working with centimeters, or meters if you are working with meters, and so on. In question 2, we are required to calculate the circumference of a circle whose radius is 21 centimeters. So here we have the radius as 21 centimeters. Then you realize that 21 is also divisible by 7. So we can use our pi as 22/7. Now, in this case, we can use pi d as a formula for calculating the circumference, or we can use 2 pi r, because what we have here is a radius. So circumference is equal to 2 pi r. So 2 times pi, which is 22/7, times r, which is 21. So by 7, 1, by 7, 3. So now we have 2 times 22, which is 44. Then 44 times 3, which is equal to 132 centimeters. If you don't want to use the formula 2 pi r, or if you can't remember it, then you can go on and from the radius obtain the diameter. We know that if you multiply the radius by 2, you obtain the diameter. So this would be 21 times 2, which is equal to 42 centimeters. So circumference is equal to pi d. So this is equal to 22/7 times the diameter, which is 42. By 7, 1, by 7, 6. 22 times 6 is equal to 132 centimeters. So no matter which route you decide to take, you will land on the same answer. So now what happens when you have a circumference and you need to determine either the diameter or the radius of the circle? So let us work out some questions involving that aspect. So now in these questions, in the first one, we have the circumference of a tin, which is 264 centimeters. This is centimeters. And we are required to determine the diameter of this tin. So in this question, we have the circumference as 264 centimeters. We also have pi as 22/7. Remember, we said the first thing that you do is to highlight what the question has provided you. So now we want the diameter. So there is a formula that connects the three. So we know that C is equal to pi d. The circumference is given as 264, which is equal to pi 22/7 times the diameter. So for us to obtain the diameter, we have to multiply both sides by 7/22, which is the reciprocal of 22/7. So multiply by 7/22. So the 7's will cancel, the 22's will cancel. Then in this case, we have by 2, 11, by 2, 132. Then by 11, 1, by 11, 12. Then 7 times 12 is equal to 84. So 84 centimeters will be equal to the diameter of this tin. And this is what you are looking for. So there it's just a matter of substituting the values that we have in the formula and then working out the rest. Now in the other question, we are required to determine the radius now, not the diameter. The radius of a circle whose circumference is equal to 220 centimeters. We know that pi is equal to 22/7. Now we can go ahead and get the diameter first. Then from the diameter, we get the radius. So circumference is equal to pi d. The circumference here is 220, which is equal to 22/7 times the diameter. So we multiply by 7/22. We multiply by 7/22. By 22, 1. By 22, 10. So on this side, they cancel out. 7 times 10 is equal to 70 centimeters, and this is the diameter. But the question is not asking for the diameter, the question is asking for the radius. Now we know that the diameter is equal to 2r. So 70 is equal to 2r. We are interested in the r, so we divide by 2 here, we divide by 2 here. So our r will be equal to 70 divided by 2, which is 35 centimeters. And that is how you determine the radius and the diameter given the circumference. Now we are going to look at another aspect where a circle is divided into two regions, not using the diameter, but using radii. And then we are going to figure out how to calculate the length of that section of the circumference. Now, in this second part of the lesson, we are going to be discussing how to determine the length of an arc. Now, you could be asking yourself, what is an arc? So, from a circle, if this is a circle, and then you have two radii from the center of the circle, like this and that. So you can see that the two radii, so this is a radius and this one is also a radius. So as a result of drawing the two radii, we have divided the circumference of the circle into two. We have a region that begins from here all the way to here, and then we have another length that begins from here all the way to here. We are talking about a part of the circumference. Now, this part of the circumference, which is just, like that, is the one that we refer to as an arc. That's why when you're doing construction and you're using your pair of compasses, you are asked to make an arc, okay? An arc is just a part of the circumference. So now, we have two of them in this case. We have this one, which is the smaller one. So this one is known as the minor arc. And then the one on the other side is known as the major arc. All right. So here we have a minor arc that begins from here all the way to here. Then we have a major arc which begins from here all the way to the other side. Now you'll also notice that this arc is subtended, okay? This arc is subtended by an angle. So here we have an angle, and this angle is represented by a Greek letter called theta, and it is drawn like a zero with a stroke in the middle. So today we have learned about two Greek letters. One was pi, which is written as, like that. And then we have theta, which is written like a zero with a stroke, and it is used to represent angles, okay? So here in the middle, we have an angle, theta, all right? Now for us to come up with the formula for calculating the length of an arc, we are going to use something that is more familiar to us. If you have a quarter of a circle, okay, if this is a quarter of a circle, then you realize that if you are asked to determine the length of this quarter of the circle, this is a former circle and so on. If you want to determine the length from here all the way to here, the formula that we know is that we take a quarter times pi d, right? A quarter times pi d, because this is a quarter of a circle. But where does this quarter come from? When you look at a quarter of a circle, we have an angle right here, which is 90 degrees. So we have 90 degrees over the total angle here, which is 360. Okay, so the whole of this, if it makes a circular turn, then the total angle is 360. Now, if you divide this, you realize that by 90 is 1, by 90 is 4. So this a quarter comes from taking 90 over 360. Now, 90 represents the angle which is between this radius and this radius. So even in this case, we have an angle between this radius and this radius, and for us to get the length of the arc, we will take this angle theta here, just like we take our 90, over the total angle, which is 360, and then we multiply by the formula for getting the circumference of a circle, which is pi d, or L is equal to theta over 360 times 2 pi r, because the other formula for getting the circumference is 2 pi r. So I hope you have understood where this formula is coming from, that we are taking, this is a segment, it is a fraction of the whole circumference. And what brings about that fraction? It is the angle that is here, or the angle that is subtending the arc in relation to the angle for the whole circle, which is 360. So the length of an arc is calculated by taking theta over 360 times pi d, or theta over 360 times 2 pi r. Now we are going to look at some questions and learn how to determine the length of an arc. So learners, in these questions, we are going to determine the length of the arcs given. So in the first one, we have an arc that begins from here all the way to here, and it is subtended by an angle of 60 degrees, and the radius of this circle is 7 centimeters. So the length of an arc is equal to theta over 360 times 2 pi r. Okay, theta over 360 times 2 pi r. So theta in this case is this angle, which is 60 over 360 times 2 times 22 over 7 times the radius, which is 14. So you can go on, times the radius, which is 7. So we can simplify by 7 1 by 7 1, by 61 by 66, by 2 1 by 2 3. So now we have 22 divided by 3, which is equal to 7.33 centimeters. So the length of this arc is 7.33 centimeters. Now next, we calculate the length of the next arc, which begins from here all the way to here. Now for us to get the length of that arc, we still use the same formula. Length of an arc is equal to theta over 360 times 2 pi r. So theta is 100 over 360 times 2 times 22 over 7 times the radius, which is equal to 14. So by 7 1 by 7 2, the zeros cancel out, by 2 1 by 2 18, by 2 1 by 2 9. So we have 10 times 22, which is 220, divided by 9, which is equal to 24.44 centimeters. So the length of this arc is 24.44 centimeters. So that is how you calculate the length of an arc, students. Now next we are going to look at, if you have the length of the arc and you have the radius, how do you determine the angle that is subtending the arc? So now we are going to determine the angle subtended at the center of the circles below. In the first one, In the first one, we have an angle. We have a sector that, when completed, makes a circle, and the radius is 10 centimeters, and the length of the arc is 12.56 centimeters. Now the angle between the two radii is theta, which is what we are looking for. So we are still going to use the same formula. Length is equal to theta over 360 times 2 pi r. So length is already given in this case as 12.56, which is equal to theta, we don't know theta, over 360 times 2 times pi times the radius, which is 10. So what we are going to do with this, we are going to take everything else to this other side and remain with theta on one side. So how do we do that? So on this side, we already have 12.56. So anything that is a denominator on this side becomes a numerator on this side. So 360 is a denominator, so now it's a numerator. 2 is a numerator, so now it's a denominator. 22 over 7 now becomes 7 over 22, and then 10 becomes 1 over 10, and this is equal to theta. So when you work this out, you find that theta is equal to 72 degrees. So 72 degrees will be equal to theta. So the angle between the two radii here will be 72 degrees. So the same thing is going to happen in the other circle. If we complete this, we form a full circle. So L, or rather the length of the arc, is equal to theta over 360 times 2 pi r. The length is 7.3, which is equal to theta, we don't know it, over 360 times 2 times 22 over 7 times the radius, which is also 10. So we do the same thing here. We bring all these values to this side because we only want to remain with theta on one side, because that is what we are looking for. So anything that is a denominator becomes a numerator. Anything that is a numerator becomes a denominator. So now we have 7.3 times 360 times 1 over 2 times 7 over 22 times 1 over 10, and this is equal to the theta. So when you work this out, you will be able to get 42 degrees being equal to theta. So the angle subtended here will be 42 degrees. So whenever you are given the length of the arc and the radius, and you are required to determine the value of the angle between the two radii, you just substitute the values in the formula, and then you obtain the value for theta. So how do we do it now when we are looking for the radius? If we are given theta and the length of the arc, are we able to determine the radius? So now we are going to do some questions on how to determine the radius. So now, learners, we are going to learn how you can determine the value of the radius given the length of the arc and the angle subtended at the center of the circle. So we are required to determine the value of r in these two figures. So for the first one, we know that the length of the arc is equal to theta over 360 times 2 pi r. The length is given as 11 centimeters, so this is 11, being equal to theta, which is 30 over 360. We multiply by 2, we multiply by pi, then we multiply by r. We are interested in obtaining r. So what we do is that we take every other number to the other side and remain with r on one side. So this will become 11, then 30 over 360 will be 360 over 30 times 2 becomes 1 over 2 times 22 over 7 becomes 7/22, which is equal to r. So now we are going to simplify. These two zeros can cancel out. Then divide by 3, 1, divide by 3, 12. Divide by 2, 1, divide by 2, 6. Then divide by 11, 1, divide by 11, 2. By 2, 1, by 2, 3. So now we have 3 times 7, which is equal to 21 centimeters, being equal to the value of r. So when you want to determine the value of r, all you have to do is to determine the value of r, to substitute the value of length in the formula and the value of theta in the formula. Let's look at it our next example. We have 18.84 centimeters and we are looking for r. In this case, I want us to use pi as 3.142. We haven't used it, so let's use it now. So length is equal to theta over 360 times 2 pi r. The length is 18.84, which is equal to 108 divided by 360 times 2 times pi 3.142 times the radius. We want to get the radius, so we can take everything else to this side. So we have 18.84 times 360 over 108. So by now we have learned that if you bring anything that is being multiplied on this side, we reciprocate it. Then 2 will become a half, then 1 over 3.142, and this will be equal to r. So what you do, you work this out, you simplify, and then you multiply for you to obtain the value of r as 10 centimeters. So the value of this radius is 10 centimeters. So again, you just need to know the value of L and the value of theta, and you can determine the value of r. In fact, whenever you're using this formula, you just need to know two unknowns, because we have three unknowns. We have length, theta, and r. So when we are looking for length, we need to know theta and r. When we are looking for theta, we need to know length and r. When we are looking for r, we need to know length and theta. So now I'm going to give you a few questions that you are going to use to determine whether you have understood what we have learned today. So now, learners, you're going to attempt these questions. Number 1, find the circumference of a bicycle wheel whose radius is 10.5 centimeters. Number 2, the length of an arc of a circle is 22 centimeters. If the angle subtended at the center of the circle is 60 degrees, then determine the diameter of the circle. Finally, an arc subtends an angle of 45 degrees at the center of the circle. Find the length of the arc given that the radius of the circle is 3.5 centimeters. I hope that you have learned something about the circumference and the length of an arc. Thank you so much for being in this lesson. See you in the next lesson.